Hello everyone, welcome back to Brain Lab Techies, and this is day 8 of our playlist Complete Statistics for Data Science. Now today the topic is mean versus median versus mode. Now why this topic? Today we will be doing the comparison between all the measurements of central tendency, because we have completed the entire central tendency in the previous videos. Now if you have not watched those videos, first complete those videos and then come to this. Let's continue from this topic. So mean versus median versus mode. So before jump into the topic today, first let's revise what is central tendency. So if I go for central tendency, it is a measurement of this phenomena. What is central tendency? Central tendency is basically a phenomena, means if I going to get some idea about a data points, I will be going for a central value which will be the main representative of the entire data points. So central tendency, it's a measurement which is giving you a basic idea, which will be the representative, or it will represents the data set. So the entire data set, like if I go to understand the performance of a particular class, so there we are not going to study all the records of each students or each student's performance. Rather we will be going for a average student's performance to understand what is the performance or what is the health of the performance of the students. So that's what central tendency is, and this is the central tendency measurements. You can say this is you can consider as a heart of the entire data set. Now we have seen mean, we already have seen thoroughly mean, median, mode. Now why these three different measurements, why it is important? So let's compare between mean, median and mode. Now, what is mean? Mean is basically the simple average. Simple average means the total values divided by total observations. So, this is a simple average, means what you will be doing, the total values, you will be adding all the values divided by total number of observations, like whatever the number of observations you have, means what you will be giving this by x bar. So the formula generally it is 1 by n summation xi, means all the values you are adding somewhere and you are dividing it by n is the number of observations. So this is how you can calculate the mean. Now, what mean is actually doing? Mean is adding all the values and dividing it with the number of values present. So, this is giving you the simple average relationship or the average representative. But whereas, let's talk about like if I go for outliers, if we have outliers, then it is doing so much problem, because whenever you are adding some value, the in the outlier, like as a outliers, whenever you are adding the total value becomes more higher or more lower. If it is a negative outlier, then the value will be reduces to very negative value, and if it is a positive outlier, then the total value will be increasing a lot. So it means it is actually going to affect the mean. Now if you are not clear about it, first I will be suggesting you to watch those videos like mean, median and mode. First watch that video, okay? So mean, so it is, we already have seen mean is like highly, this is highly affected by the outliers. Then why we use mean, or where we can use mean as a central tendency measurement? So in the normal calculation, or the where the data set is not having so much outliers, mostly the data set, if the data set is somewhere normally distributed, if the data set is normally distributed, then only we can directly apply mean as a measure of central tendency. But what about the skewed data? So for that we have median. Now what is median? Median is basically the central tendency, what actually indicating the middle value after sorting all the values. So it is a middle value. If I say for median, median is basically the middle value. So median is the middle value that we will get by sorting the values by sorting all values. And we have seen for median we have some separate formulas. If your number of observation, so number of observation, if it is even, means let's suppose, let's take this number of observation as n. Now let's see two cases. If n is even and n is odd, if n is odd, first of all, then it will be like after sorting the value you will be get n plus 2th value as the middle value, or it will be considered as the median. Whereas if your n is even, for that case what you will be doing, n by 2th value plus n by 2 plus 1th value. Now these two value you will be adding and dividing it by 2. Now this is what for median when your number of observation is even. Now what about the outliers? As because you are sorting the value and it is indicating the middle value, so it's not like it is not at all caring about what are the outliers present in the data, because the outliers is mainly present at the last of the data set. So in the middle you will not get any such of outliers. So middle value means median, so it is completely not affected by outliers, because only it is concerning about the middle value after sorting it. So always if it is a positive outlier then it will come at the left side, or if it is a negative outlier then it will be going for the right side. So that's why middle value will be the median. So it is not caring about the outliers, not at all, so it's not affected by the outliers at all. So what about this median, where we will be using this median? So if I go for the application, like what will be the data set nature? So the nature of the data set will be skewed. If your data set is skewed data, means if it is positively skewed, means this type of data or this type of data, either positively skewed or negatively skewed. This one is the positively skewed examples. Positively skewed data means the asymmetric data, and for negatively skewed data. Now for both type of data we will be using median rather than mean. So for bell shaped we will be going for mean, whereas for skewed data we will be going for median. Then where to mode? Now what is mode? Mode is basically most frequently occurred value. So it is basically, mode is basically that value which is most frequently occurred value. Now this is completely not depending on the value of the variable, whereas it is actually depending on how many times it is occurring, because it is depending on what, it is depending fully on the frequency, how many times it is occurring. Like customer purchasing behavior, if you're going to understand average customer purchasing behavior, for that you will be seeing that which is a most purchased product, that will be the central tendency of their purchasing behavior. So depending, it is completely frequency depending on frequency. So here also if we have some outlier, obviously those outliers will not come in a bulk. If those outliers is not coming in a bulk, so it is not going to affect the mode at all. So mode is basically having the highest frequency and it is not affected by the outlier at all. Then where to use mode? So basically frequency, we have frequency type of data only for those data which is having so much categorical data. Means when we are not having those type of data which is consisting of numerical data, means if we don't have numbers, then what calculation we will be doing there? Let's suppose for purchasing some products, that particular product is a value, like product is the only value, the product name is the value, but we can't do any calculation. We can't calculate the average by the name of those product, whereas based on the purchase, like how many times it is being purchased by the customer. Based on that we can surely calculate the mode. So basically where to use when the data set is actually not having any numerical value, whereas the data set is consisting of categorical data or categorical values, means those values are not in numeric, not quantitative data, whereas it is qualitative data. So for categorical data we can use mode. So for that, mode is a good central tendency measurement. Now these are all the different comparisons we already have. Now what are the relationship? So if I go for different type of data set, so let's talk about data set. So data set is having two types of nature, like one is symmetric, and other one is asymmetric nature. So this is what asymmetric nature. Now for symmetric nature means, if it is symmetric means it is fully bell shaped. Now bell shaped means what? Normally distributed data. So this is what also called normally distributed normally distributed data. Or the curve, you can also call it is Gaussian curve means what? Fully it is bell shaped. So if I draw this type of bell shaped data, and if I talk about the mean median mode like as a measurement of central tendency, so it will be like this, as because this is fully symmetric data. So this is the only point that will be the representative of everything, because this is the only median, and this is the only mode. So for symmetric data, for normally distributed data, always mean equal to median equal to mode. It will be always like that. But what about for asymmetric data? Now for asymmetric data, if we talk about asymmetric data, means what? Asymmetric data means always it is skewed data, means it will be having a skew either in the positive direction or in the negative direction. So it is skewed data. Now why this skewed data, or where we will be getting this different central tendency measurement? So let's talk about positively skewed data. So positively skewed data, if we take positively skewed data, means the skewness is in this direction, in the right direction. Now let's draw the axis, because it is important, this axis also important. So I'm just drawing the axis. Now let's understand the central tendency. So from this hump, as because this is the mostly, like this is the highest frequency by visualization we can observe. So this point is actually the indication of mode. This is the mode. Now as because the outliers, as because this is a skewed data set, because that's why the outliers is actually situated in the positive direction, because here we have in this point of is in this region we have positive outliers. Now because of these positive outliers, there will be one influence on mean. So the mean will be situated somewhere in this position because of the presence of the outliers. So mean will be in this position, whereas median will be situated in between mean and mode. So median is a value which is a middle value, which will separate the entire data set into 50-50 ratio. So it will be the median. So always for positively skewed data, this type of value you will be getting. So here as you can see, this is the value of mode, and for median this much will be the median, and for mean as you can see here, this much will be the mean. So from this it is very evident that what is the relationship between mean, median, mode if it is positively skewed. So here you are getting that mode is coming, and this is the lowest value, and median will be greater than mode, and mean will be more greater than median. So this is how you are getting the positively skewed data, and this is a situation for the different central tendency. Now let's talk about negatively skewed data. Now for negatively skewed data, if I draw again the same type of data set for negatively skewed data, what really happened? Now again I am drawing the same kind of skewed data set, and right now it is negatively skewed means it is the, like all the outlets it is there in the beginning, so the data will look like this. Now from this data it is very evident that this one is the measurement of mode, because most of the frequency are holding here only, so this one is the mode. Now what about the mean? Obviously here you are getting the mean as because it is still it like it is having some negative outliers, and because of the presence of this negative outlier the mean is getting affected, so the mean is coming in this position, so mean will be like that. And median, as for always, median will lie in between mean and mode, so this will be your median. So now if we talk about like how much the data it is holding, so and this much value is the mean, and after that if you see this much value is holding by the median, and for mode this much value is the mode. Now from this it is very evident that here mean is the lowest value holding as a central tendency measurement, whereas median will be median sorry guys, this will be the symbol. Okay, so median will be still much bigger than mean, and mode will be the highest value will be holding as a measurements of central tendency. So for different situation we will be having different cases. If your data set is a fully symmetric data set, or it is a Gaussian curve or bell shape, then always your central tendency will be same, like three central tendency we will be like having has, or the same value it will hold. Whereas if it is like, if you see, like these are of the observations, if you see like mean is highest and mode is lowest, for that you will get the idea that your data is positively skewed. Whereas if your mean is lower than median, and median is lower than mode, then you will get the idea that your data is negatively skewed. So by this nature of mean, median, mode, you can get the idea about the distribution. So this is how you can do it. Now lastly I need to add one more line, that is empirical formula or empirical relationship between all this central tendency measurement means empirical relationship between mean, median and mode. So what are the formula? Like only one relationship it is there, that is the deviation between your mean minus mode. So this deviation will be 3 times the deviation between mean minus median. So this one is the empirical relationship between mean, median and mode. So this is all about all the relationship and comparison between mean, median and mode. So this is the last video of central tendency. Now from tomorrow we will be looking for the mean deviation. Standard deviation means the measure of dispersion. So this is all about today. Now if you have any doubt, you can directly comment, and I can I will clear your doubt in the comment only. So stay tuned guys, thanks for watching, bye bye.